Here's an example of a logarithmic function on ALEKS that we want to graph. For graphing on ALEKS, we're required to plot at least 2 points on the graph, draw asymptotes, and then click on the graph icon. This function is 4 times log base 3 of x. Now, multiplying by 4 is a transformation that we haven't really discussed, but it would create a vertical stretch on the graph. So it doesn't shift it up or down, left or right, it just stretches the graph and makes it increase more quickly. So the normal graph of log base 3 of x is going to have a vertical asymptote at x equals 0, and it has an intercept 1 to the right at 1, 0. So I'm just going to be stretching this graph by 4. So I need to figure out 2 points on the graph. Well, first, if I stretch this point by 4, I would expect that since it hasn't shifted left or right or up or down at all, that this ordered pair at 1, 0 is going to stay there because the y-coordinate is 0, and if you multiply it by 4, it doesn't change 0 at all. So I would graph first 1, 0. So there's one ordered pair. To find another ordered pair, you can take the equation and rewrite it as y equals 4 times log base 3 of x, and then you can get rid of the log by doing exponential form. The problem is we have this 4 that's in front of the logarithm. So we learned properties of logs allow us to take coefficients and they come up as exponents. So y equals log base 3 of x to the 4th. So then I would do exponential form. Get rid of the log, start with the base of the log, 3, cross over to your power, y. So 3 to the y equals x to the 4th. So some power of 3, and then I want to have x to the 4th over there. I'm going to have to do a little bit of work to solve for that. So pick an easy power to solve for. I can see here, you can pick really anything. You're picking powers for y, so you're doing powers of 3 really. So I could pick, 1, 2, 3, 4. I can even do negatives, but I want to pick something that's easy for me to plot. If I plug in 4, and the reason I'm focusing on 4 is because I have a 4th power over here, I think that's going to be an easy one for me to solve. 3 to the 4th is 81. So that would give me, well, that's not my solution, but that would give me 81 over here, and I have 81 not equal to x, but equal to x to the 4th. And then to solve for x, I'm going to have to 4th root it. So I'm thinking, what number raised to the 4th power is 81, and it's just 3. So I should have an ordered pair at 3, 4. So again, backing up, here's what I did. I started with the equation y equals 4 times log base 3 of x. I wrote it in exponential form after I pulled this power up. So y equals log base 3 of x to the 4th. Now I can start with the base of the log, 3, cross over to the power y equals the part after the log, x to the 4th. So if you wanted to get x alone, you would 4th root both sides. The 4th root of 3 to the y is equal to my x. Make a table of values, plug in for the y, and make it easy so that you can solve quickly. So since I have a 4th root, if I make y match the root, it's a very easy one to solve. The 4th root of 3 to the 4th is just 3. So I have a second ordered pair at 3, 4 that I can plot. ALEKS then requires you, after you plot the points, to draw your asymptote. So I'm going to sketch this vertical asymptote at 0 since it didn't move anywhere, and then I click the graph icon. The graph icon on ALEKS looks like this, where you have these little dots, little X's on the graph of the logarithm. You just click on that button and it's going to connect the dots for you, and then you can finish your graph.